Yes, sir.
Thanks, sir. Last chapter.
Oh, okay. Same.
Like, I don't know physics part physics is practice.
లేదు వాళ్ళు లేదంట
ఆ బుక్స్ బాగుంటుంది బాగుంది అన్నారు కదా
చేస్తున్నాను
నారాయణ సెలక్షన్ చేశారు
Assalamu alaikum to everybody. We were discussing problems based on thermochemistry. Let us take next problem. I don't know number. This is a number. Find heat of formation of isoprene. Enthalpy of formation of isoprene. He said something like this. Isoprene, but he has given the structure of that one. Isoprene is given to be as CH2 double bond CH3 single bond CH double bond CH2. You have finished nomenclature of organic chemistry. It is called 2-methyl it is called 2-methyl 1,2 butadiene. We are not interested in the name of the compound. We want to know the structure. That's is asking find the enthalpy of formation of isoprene. The data given to you is bond energy of CH. Bond energy of CH bond is equal to 98.8 kilocalories. Bond energy of HH bond is equal to 104 kilocalories. And bond energy of C single bond C is equal to 83 kilocalories per mole. Bond energy of C double bond C is 147 kilocalories. And one more thing he has given, enthalpy of atomization of carbon. Enthalpy of atomization of carbon is 171 kilocalories. And he's asking find the heat of formation of isoprene. Okay, whatever with the isoprene, if you want to solve the question, that should be done something like this. I said in the previous classes, whenever you want to have formation of a substance, we should write the reaction in a reverse manner. It will be comfortable to you. It's not necessary, it is comfortable to you. It's not a rule, it is comfortable if you write formation reactions in reverse direction. Therefore, suppose for example, if I am saying that we are having this reaction, what is that? CH2 double bond 1, 2, I'm not writing again this structure. Wait a minute. I'll write this structure here. I am lazy fellow. You write down that one. We have 1, 2, 3, 4, 5. What I should write? 5 carbons plus 2 plus 1, 3 plus 3, 6 plus 2, 8, 4H2 gives you C5H8. This is isoprene. Now, this is enthalpy of formation of isoprene. No, sir, it is enthalpy of reaction. When you said the word enthalpy of reaction, in the previous classes we have done enthalpy of formation of products minus enthalpy of formation of reactants. But now the discussion is in terms of bond energy. Therefore, what we have done in the classes, bond energy of reactants minus bond energy of products. Fine. Now, bond energy of reactants. How to proceed? Very simple, sir. See this structure. See this structure. This is product here. Reactant is this one. So I have to start with bond energy of carbon. That there is no bond in carbon. Wherever there is no bond in that system, we have to use enthalpy of atomization. So reactants, enthalpy of atomization of carbon, but how many times? 5 times. Plus enthalpy of hydrogen. Now hydrogen has a bond, right? And he has given the bond energy. Therefore, I should write bond energy of which bond? H bond. How many times you have to write? 4 moles. We have to write 4 times. This is known as bond energy of reactants minus bond energy of products. What is the meaning of bond energy of products? Come here. First of all, let us talk about double bond, right? So bond energy of C double bond C. How many times? Here we have C double bond C, here we have C double bonds. That means dash times. 2 times plus. Let us come to one by one. Bond energy of C single bond C. Right? C single bond C 1 time, C single bond C 2 times. Therefore, 2 times. Plus bond energy of C H bond. CH bond. Here we are having 2, here we are having 3, 5, 6, 7, 8. That means 8 times bond energy of this one, right? So we have all double bond we have counted, C double bond C, then we have counted C single bond C, then we have counted C single bond H. We don't have HH bond there over. All the values are given to you. Atomization of carbon is given to you. Right, bond energy of HH 104 4 times, C double bond C given, C single bond C given, CH. If you arrange as it is and calculate, that answer will be in terms of kilocalories. That is known as enthalpy of formation of isoprene. Go ahead. Is it over? $20.6 kilocalories with positive sign. Excellent. Very good. Next. Now, whenever you have problems of bond energy, you have to enjoy like this. Next question. Heat of atomization of ammonia. See the way of giving the question. Heat of atomization of ammonia and hydrazine. Heat of atomization of hydrazine into H4 are X kilocalories per mole and Y kilocalories per mole. X, Y kilocalories per mole. Find average bond energy of N single bond N. Find bond energy. He is using the word average bond energy of N single bond N. Okay, now see how to proceed. When I go back to my class notes, what I taught you, atomization is a word suitable for carbon. Atomization is a word very suitable for hydrogen actually. And if you are talking about carbon, okay sir, forcefully we accept it as atomization is nothing but the amount of heat energy required for conversion of non-suitable form of carbon such as a solid graphite to suitable form of carbon as we have used in the previous case, right? But here he has given a triatomic system. Nothing to worry. Atomization means formation of atoms. So don't take any tension and stress. Simply go along with the language as he is using the atomization of NH3 means try to create atoms. Try to create atoms. That means if you want to do this type of process, whatever the amount of energy is required is called enthalpy of atomization. That is given as del H is equal to plus X kilocalories per mole. Okay. Now N2H4. How do we proceed further? Nothing to do, sir. Let us write N2H4, which is also in the form of gas. It will give you 2N plus 4H atomization, right? If you are having this type of situation, then we can say del H is equal to Y kilocalories per mole, right? Now, suppose for example, if you are taking this, then what we can say, sir, if suppose you are calculating del H1, what is del H1? This is X. We are talking about X, right? Now, problem examiner is saying it is X, but I want to look this in a different manner. What actually I have done? Very simple, sir. I have broken up 3 bonds. And which bonds? NH bonds. Therefore, examiner or the paper setter is saying that it is heat of atomization. But I am saying heat of atomization of ammonia, his language. My language is no, sir, it is bond energy of NH bond dash times is equal to X. Bond energy of NH 3 times is equal to X. That is another way of representation. Similarly, when we are discussing N2H4, right? N2H4, how it looks like? Therefore, if suppose for example you are saying enthalpy of atomization as per the language of examiner or book paper setter, you can say no sir, this is nothing but bond energy of NH. How many times? 4 times. NH, 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 and bond energy of dash, N single bond N. And what is this? This is Y. No, sir, this implies 4x. No, what is that? Here writing bondage of energy. What is this? 4 times x by 3 plus, I don't know this value. Say, for example, alpha is equal to y. What is alpha? Enjoy it. Go ahead. 3y minus 4x upon 3. Yes, you're right. Kilocalories per mole. Excellent. The answer is, he's saying 3y minus 4x whole upon, yes, this is correct. Mustafa is saying this. Anybody else? Okay, no problem. Let us go to next question. Is it over? No one is saying, I thought there is no one in our classroom who can have a property to give answer. Abrar, is it over? Saidur Rahman, finished. Abrar, done. Very good. Next. Next question is, now this is actually a very big question. Long discussion is there, IIT 1990. But I enjoy this question for my students who are really interested to solve the problems of this type. Using the data at 25 degrees centigrade, all in kilocalories per mole, find bond energy of CC bond energy of C single bond C, bond energy of C double bond, no, C single bond H. He's asking bond energy of CC and CH bond. And what is given to you? So many things are given. What is that given? I'll tell in terms of names. He has given equations, but if people are genius, enthalpy of atomization of carbon 172. Enthalpy of atomization of hydrogen 52. Enthalpy of combustion of hydrogen minus 68. Enthalpy of combustion of carbon minus 94. Chalo, theek hai. Then enthalpy of combustion of ethane. Enthalpy of combustion of ethane minus 372. Enthalpy of combustion of propane C3H8. Currently available. C3H8 is given as minus 530 kilocalories per mole. That's all. This is the data given to you. How to proceed? Nothing, sir. If suppose you have very large data available, it means question is simple. Those questions which are short and sweet, they force you to think more. Those questions which are having so much information, thought process will become minimized. Come on. I'll take combustion and combustion. First of all, I'll take combustion of ethane. Go ahead. C2H6 plus oxygen gives you carbon dioxide and water. 2 carbons available, 6 hydrogens are also available. 4 oxygens plus 3 oxygens, 7 oxygens are also available. If you want to write enthalpy of combustion of ethane, no sir. May I call as enthalpy of reaction? No problem. Come on. How to proceed for this? Very simple, sir. If we are discussing this, it is nothing but here he has given in terms of bond energy discussion. So I should go in terms of bond energy only because I am having necessity of bond energy. Come on. What is to be done? Bond energy of C2H6. Who is that fellow? Something like this. Therefore, C single bond C 1 time plus bond energy of CH bond. How many times? 6 times plus 7/2 times bond energy of oxygen. Right? Is it given to you? Is it given? No, not given. Not given. There is a problem. You cannot go like this. You cannot go like this. How to proceed? Okay, sir, if I am unable to get bond energy of oxygen here, then there is a problem here. What is to be done? What I'll do here, I'll take ethane and formation of ethane, I'll write. C2H6. 2 carbons plus 6 hydrogens. Okay, if it is so, now I can write enthalpy of formation. Enthalpy of formation of ethane is equal to, let us take bond energy of carbon. No sir, there is no bond in the carbon. Therefore, what I should write? Atomization of carbon. Please have a look on the data. Atomization of carbon. Is it available? Is it available? Yes. Atomization of carbon is available. How many times? 2 times. Plus enthalpy of atomization of hydrogen. Is it available? Yes, sir. How many times? 6 times. Minus bond energy of C single bond C. I don't know. How many times? C single bonds. 1 time. Plus bond energy of C single bond H. I don't know that also. How many times? 6 times. Now, enthalpy of formation. There will be a big doubt in your mind. Sir, formation of this is also not given. No problem. I'll create from here because enthalpy of reaction is equal to, come on. Enthalpy of formation of carbon dioxide 2 times. Is it given to you? Yes, sir. Combustion of carbon is formation of carbon dioxide. We know it. Similarly, enthalpy of formation of products, water. How many times? 3 times. Is it given to you? Yes, sir. Enthalpy of combustion of hydrogen is nothing but enthalpy of formation of water minus enthalpy of formation of ethane. Yes. Plus 0. You people are genius. There's no need, you can understand. Because you have very good homework. Daily you have to do work and you are doing work daily 1 hour at home. Therefore, you can understand properly. Do you know the value of enthalpy of reaction? Yes, sir. Combustion is given to me. This 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 I have calculated. That I substitute here. And then after that, what I do? I know this value is equal to 2 times enthalpy at atomization of carbon. Yes, sir. It is also given. Why to write unnecessary? We can do no. Come on, given plus atomization of hydrogen, sir, given minus bond energy of carbon demanded. Let us say X CC bond plus dash 6Y. How many unknowns? 2 unknowns. Keep that equation as it is. Now I will not do this problem. What I'll do? I'll just explain you. Okay, come on. C3H8 propane. Same story. Cheating. C3H8 plus space oxygen is equal to 3 carbon dioxide plus 4H2O. 3 carbon dioxide means 6 oxygens. 4H2O means 4 oxygens. 6 plus 4, 10. 5O2 gives you this one. Okay, again enthalpy of reaction is equal to all this. From that, find out enthalpy of formation of propane. And once you find enthalpy of formation of propane, again write down this reaction where you are having atomization of carbon and atomization of hydrogen along with CC bond and CH bond. How many unknowns? 2 unknowns. 2 unknowns, 2 equations. You are genius. Go ahead. जिसको समझ में आया है, enjoy the beauty. जिसको समझ में नहीं आया है, don't take tension. Don't take tension. Life is given to enjoy. Try slowly, systematically, stepwise. Today, I hope we'll finish thermochemistry problems. Go slowly, go slowly. You didn't get the point? See the screen carefully. I hope you can get the point. All right. The question is to involve in the classroom. You have to see the screen carefully. Then you definitely will enjoy. What Muhammad Mustafa? 82 kilocalories. CC bond energy. You are excellent. CH bond energy 99. Very good. Very good. Excellent. Is it over? Write down the answers. X is equal to CC bond energy is 82 and CH bond energy is 99 kilocalories per mole. Come on, come to next question. Is it over? Come on. Come to next question. Now, I am switching over to another model. And this is a very useful number of times asked. Calculate the resonance energy. Okay, no problem. Resonance energy. Calculate the resonance energy. Okay. Of N2O from the following data. The data is given like this. He says enthalpy of formation, standard enthalpy of formation of N2O is equal to 82 kilocalories, 82 no, kilojoules per mole. Okay. Next he said bond energy of N triple bond N, (946) kilojoule per mole. N double bond N, 418 kilojoules per mole. O double bond O, 498, and N double bond O, 607 kilojoules per mole. That's all. Right. Now, how to proceed for this? Very simple, sir. Right, as we have learned in our notes, resonance energy is experimental value minus calculated value. Experimental value minus theoretical value. Okay. So what is the meaning of experimental? What is given to you in the question is called experimental. He has done some experiment and he has given the value. And what is the meaning of calculated value? This is using this data. Whatever you are calculating is called theoretical value or calculated value. Okay, come on, go ahead. How to proceed for calculations? Formation of N2O. What is the meaning of formation? Write in reverse order. N2O is equal to, how to proceed? Very simple, sir. This N2O is supposed to be N2 plus dash half O. And since the data is all bond energy, I will try to enjoy the bond energy in terms of bonds who are available here. Yes. This is the way of writing the bond energy. And there is a help here. See the triple bond, double bond, double bond. Everything is available. So it means we are going on the right path. Now, enthalpy of formation of N2O is equal to, this is what calculated value, theoretical value, bond energy of reactants. Who is that fellow? N triple bond N plus half time bond energy of O double bond O, minus bond energy of N double bond N, okay, products, plus bond energy of N double bond O. Yes, that's all. All the values are available. You got something. Who is that fellow? Alpha. Now, resonance energy is equal to enthalpy of formation, whatever it may be, experimental minus enthalpy of formation, theoretical. Go ahead. That is the way to calculate the resonance energy. Answer. Demand of the question is resonance energy. Go ahead. Resonance energy is 88 kilojoules per mole. Are you getting positive 88 or negative 88? Yes, Saeed Rahman is saying negative 88. Remember, when you calculate the resonance energy, always your answer will be negative. But yes, it is negative, right? But remember one thing, when you are going to report the answer, it should be given positive value. So आप कैसा करेंगे इसको? We have tried this as minus 88 kilojoules. What is resonance energy? Released. Therefore, we say resonance energy is equal to, we don't use positive, negative sign here, 88 kilojoule per mole. This is the way of writing the answer. Okay, we should get negative number. It is necessary to get negative number, but then we have to realize the concept that, sir, we are talking about the amount of energy released, right? Next. Come on. Similarly, let's enjoy one more question with respect to resonance energy. Calculate the resonance energy of benzene. Okay. Resonance energy of benzene. How much? Using Kekulé formula for C6H6 from the following data. What is given to you? Enthalpy of formation of benzene experimental value is given to you as minus 358.5. Okay. And that is in terms of kilojoules per mole. Nice. Next, heat of atomization of carbon. ठीक है? Heat of atomization of carbon is equal to 716.8 kilojoules per mole. Bond energy of CH, comma, CC, comma, C double bond C, comma, HH are 490, 340, 620 and 437. Of course, kilojoule per mole. Done. This is the question. Nothing to worry, sir. Let us try to form the methane. How to benzene? How to prepare the benzene? Sir, formation reaction means we should write in a reverse manner. C6H6. 6 carbons plus 3 hydrogens. 3 moles of hydrogen. Come on. Enthalpy of formation of benzene. This is called theoretical value. This is called calculated value. Right? Is equal to bond energy of carbon. No, sir, you are wrong. You should say enthalpy of atomization of carbon 6 times plus bond energy of hydrogen. Yes, it is CH bond. Right? Bond energy. How many times? 3 times minus. This fellow is something like this. KK. Come on. Bond energy of C double bond C. How many times? 3 times. Plus bond energy of C single bond C. How many times? 3 times. Plus bond energy of C single bond H. How many times? 6 times. Enthalpy of formation. What is that? I got alpha. Resonance energy is equal to enthalpy of formation of benzene experimental value minus enthalpy of formation of benzene, which value? Calculated value or theoretical value. Answer is beta kilojoules per mole. Go ahead. Answer is 150 kilojoules, and you should not report the negative. It should come minus 150 kilojoules, and you have to report it as 150 kilojoules with the removal of negative sign. Saidur Rahman, Muhammad Mustafa, you got the answer. Saidur Rahman, where you have done somewhere mistake in calculations. Okay. Answer is 150 kilojoules per mole. You should get negative answer. Minus 150, it's correct. After you have to report it as yes, this implies resonance energy of benzene is 150 kilocalories. Right? That is the way of answering the question. Right. Okay. Go ahead. Go ahead. Yes. Luckily, in here, in Rajahmundry also, we are doing revision. We are doing revision for senior students. Thermochemistry was the topic today morning. I got a very good question here. Let us take that question, last question of this discussion. Enthalpy of neutralization of weak acid. Enthalpy of neutralization of weak acid in 1 molar solution with strong base. With strong base is minus 56.1 kilojoule per mole. ठीक है? No problem. The enthalpy of ionization of the acid, enthalpy of ionization of the acid, which acid? Naturally, weak acid, is equal to 1.5 kilojoules, 1.5 kilojoules per mole. Enthalpy of neutralization of strong acid and strong base, enthalpy of neutralization of strong acid and strong base is equal to 13.7 we said kilocalories. It is minus 57.3. Doctors, you can enjoy this number, you can memorize. Scientists, ये तो दिमाग में रहना जरूरी है, otherwise it is not possible to call you a scientist, right? It is kilojoule per mole. हम जो बताए थे आपको 13.7 kilocalories per mole था. चलिए, what is the percentage ionization of weak acid? He's asking, what is percentage of ionization of weak acid? ठीक है, चलिए अब यहाँ क्वेश्चन का डिस्कशन होने के बाद आपका जवाब क्या होगा कि सर ऐसा टॉपिक तो हम क्लास में नहीं पढ़े हैं. ठीक है, हम क्या पढ़े हैं सर? हम ये पढ़े कि इन केस ऑफ स्ट्रॉन्ग एसिड स्ट्रॉन्ग बेस एंथैल्पी ऑफ न्यूट्रलाइजेशन इज कांस्टेंट मैक्सिमम एंड minus 13.7, magnitude is 13.7 kilocalories, that is 57.3 kilojoules. And we have learned one more point that if the acid or base becomes weaker and weaker and weaker, the relative strength will be also decreasing. Okay, and we have measured enthalpy of ionization as the difference of mod of enthalpy of neutralization, right? Let me recall the formula. Enthalpy of ionization of weak acid is equal to, it is there in your notes, enthalpy of neutralization of strong acid and strong base minus enthalpy of neutralization of weak acid and strong base. Chaliye. What is this? This is a mod 57.3 minus 56.1. Therefore, 3 minus 1, 2, 7 minus 6, 1, 1.2 kilojoules per mole. It is called enthalpy of ionization of weak acid, which we have calculated. But he already declared enthalpy of ionization of weak acid is 1.5. Yes, it means to say when you take 1.5 kilojoules of energy, it causes 100% ionization. No, sir, I'm having only 1.2 kilojoules, therefore it will be less than that. Hence, he is asking percentage ionization of weak acid. Therefore, supermarket problem. How to proceed? Sir, if it is 1.5 kilojoules, total percentage ionization is 100. If it is 1.2 kilojoules, how much? 1.2 into 100 upon 1.5. Decimal out. 3 fours and 3 5, and this is dash 20. That means we have dash percent ionization of the acid. Go ahead. अब थोड़ा सा यहाँ पे, is it over? Shall I proceed? There is one sentence which changes the answer. This is not the answer. Shall I proceed? No. The problem is, sir, when I am talking about 1.2 kilojoules, 80% is already ionized because of this. But he is saying the energy is 1.5. इसका मतलब जो बचा हुआ है वो भी हो चुका. Are you able to understand? When I am discussing about 1.5, this is the actual value. But when you take the values which has given to me, that is giving 80%. So when you are discussing 80%, remaining 20% will be ionized because of the strength. Therefore, ये 80% आने के बाद क्या करना है? This implies, याद रखिए, this has been done if it is 1.2. He is saying 1.5. He is saying 1.5. Therefore, 80% is already its natural property. The additional property is, this implies 100 minus 80, 20% of the acid. Option में 80% भी रहेगा और वो पहला रहेगा. 20% of the acid is ionized because of that situation. Really it is 80%, but because of that acid and base discussion is ionized. यहाँ तक आके हाथ रोकना नहीं है, यहाँ पे आगे बढ़िए. Take down that, and that is the end. There is no end. Remember, physical chemistry में कोई भी एक कहता है कि this is the end of the problems. You don't know what is physical chemistry. There is no end. But we have time limits, therefore we have to complete the syllabus. I have done, to be honest, concepts I have done 100%, but problems, याद रखिए, I have done only 25% job. All types I have covered. अब उसके ऊपर आप थर्ड प्रोसेस कीजिए, कितने प्रॉब्लम्स आप कर सकते हैं, जितना आप दूर दौड़ सकते हैं, that is your way, right? Sir, I have to do all Avasthi problems, sir, I have to do some other books. Go ahead, try to solve as many possible questions as you can do. In your study material given by MS, we have plenty of problems available there. Proceed. Thermochemistry, whole chapter is over. Thermodynamics, part 1 is over. Now we are having thermodynamics part 2, right? Tomorrow, I can start the process, but it will be in between. Therefore, now our next class will be on Monday. Our next class will be on Monday. Be careful about that one. In between, if you have test, I don't think that you have test on Sunday. Is it declared because you are running with IP something exams? Any test is there on Sunday for mains or NEET? No, very good. Go ahead with your IP preparation. Yes, one boy is saying yes, sir. One boy is saying no, sir. Okay. We have test Saeed Rahman, JL40. How it can be JL40 test and JL41 no test? What about JL41? We don't have IP. Saeed Rahman exams. JL40. What about JL41? No one is there in our class with JL41. JL41. Okay, no problem. Very good. We are having class on next Monday. We'll start thermodynamics part 2. Thank you.